Hi, I'm Tina from Prep 101. In this video, I'm going to teach you how to do the derivatives of exponential and polynomial functions. There are lots of questions on the midterm and the final involving derivatives. And of course, you need to know your derivatives so that you can learn your antiderivatives really well throughout the course. Okay, let's get started. Okay, so we're going to do a whole bunch of examples of finding the derivative. So part A here, we have f of x equals 3x cubed. So our derivative here would be 3 times the derivative of x cubed, which would be 3x squared. So 9x squared. And of course, if you can get the answer 9x squared right away, then that's great. For the second one here, we have f of x equals x squared times x cubed minus 4. So we have an f and a g here, so we can use the product rule. And so our derivative will be f prime g plus g prime times f. So derivative f prime of x, derivative of the first, derivative x squared would be 2x times the second left alone, plus derivative of the second, so derivative x cubed minus 4 would be 3x squared. Derivative of negative 4 would be 0, so we don't need that. And then times the first, which would be x squared. And we can multiply this all out. This would be 2x to the 4 minus 8x plus 3x to the 4. And if we collect our like terms, the 2x to the 4 and the 3x to the 4 are like terms. So we can say 5x to the 4 minus 8x. Okay, the next one, part C, we've got x squared plus 1 on the top over 2x minus 5. So this is a quotient rule. So we have an f over g here. And so our derivative is derivative of the top, f prime, times the bottom, g, minus derivative of the bottom, g prime, times f, all over the bottom squared. And that's our quotient rule. So f prime of x, derivative of the top, derivative of x squared plus 1 would be 2x, times the bottom, 2x minus 5, minus derivative of the bottom, derivative of 2x minus 5 would just be 2, times the top, x squared plus 1, all over 2x minus 5 squared. So if we multiply this out, let's see what we get on the top here. Make sure you do this as negative 2 times x squared plus 1. So 2x times 2x, so 4x squared, minus 2x times negative 5 is a minus 10x. Negative 2 times x squared is minus 2x squared, and negative 2 times 1 is negative 2. All over 2x minus 5 squared. And if we collect our like terms there, we've got 4x squared minus 2x squared, so that'd be 2x squared minus 10x minus 2, all over the same denominator, 2x minus 5 all squared. Okay, so for part D, we have f of x equals x squared, bracket, x plus 1 cubed. So this is something involving x times something involving x again. So this is a product rule. So we have derivative of the first, f prime, times the second, g, plus derivative of the second, g prime, times f. So let's write out our product rule here. Derivative of the first, derivative of x squared would be 2x, times the second, left alone, so times x plus 1 cubed, plus derivative of x plus 1 cubed, so we need the chain rule there, so 3 out in front, times x plus 1 squared, times the derivative of x plus 1, which would just be 1, and then times the first, which is our x squared. So this here is our f prime, this is g, this whole thing here is g prime, and then this is our f. And usually they'll ask you to factor your answer, so if you look at these two terms, so here and here, and look at what's common, what you could take it as a common factor. You could take it an x, because this has a 2x and this has a 3x squared. So we could take it an x, and we could also take out x plus 1 to the 2, the smaller of the two exponents. So in the first term here, we're missing the 2. We've got the x, and we need x plus 1 to the 1, plus, right here. Here we need the 3. We have x plus 1 squared already, and we need x squared, and we have an x. So that would be an x there. Here we would get x times x plus 1 squared. here we would get 2x plus 2 plus 3x. And so it would be x plus 1 squared times 5x plus 2. Okay, part E. F of x equals something to the 10. So we have x cubed plus 3x squared plus 1 all to the 10. So our derivative would be 10 out in front. X cubed plus 3x squared plus 1 to the 10 minus 1 is 9, times the derivative of the bracket over here by the chain rule. And the derivative of x cubed would be 3x squared, plus the derivative of 3x squared would be 6x, and the derivative of 1 would be 0. And that would be our answer. And we could put this out in front with the 10, but it would be the same answer. Okay, so this one here for f, it's a square root, so we have to be careful. We don't want to start the derivative until we write what that means. So a square root is the same as x squared plus 3x plus 1, all to the exponent of 1/2. So our derivative here, it's the chain rule. So it's just like the one where we had something to the 10. So something to the 1/2. The half comes out in front. The same bracket, x squared plus 3x plus 1 to the half minus 1. A half take away 1 would be negative a half. And then times the derivative of the bracket beside it here. So the derivative of x squared plus 3x plus 1 would be 2x plus 3. And they'll always get rid of the negative exponent. So if we get rid of that, we do so by putting it on the bottom, and that will make it a positive exponent. We leave the 2x plus 3 on the top, and the 2 is on the bottom, so we leave it on the bottom, and we just bring this down and make it positive a half. And of course, if it is a half, then we know from the original that they'll write that back as a root. So our final answer will be 2x plus 3 over 2 times square root x squared plus 3x plus 1. Okay, and G, we have f of x is x plus 2 over x plus 3 all to the 7. So we'll think of this as a massive chain rule question. So something to the 7, the derivative would be 7 out in front times the something to the 6, and then times the derivative of the something. And the something in the bracket is an f over a g, so we're looking at the quotient rule here. So we need to do f prime g minus g prime f over g squared. That's our quotient rule. So we'll do a big square bracket. Derivative of the top, derivative of x plus 2 would be 1 times the bottom, x plus 3, minus derivative of x plus 3 on the bottom would be 1 times the top, x plus 2, all over x plus 3 squared. So we'll leave this for a sec. We'll write this as x plus 2 to the 6 over x plus 3 to the 6. And when we multiply this out in the bracket here, we've got x plus 3 minus x minus 2. And we've still got the x plus 3 squared on the bottom. So in this case of the brackets here, the x and the negative x would cancel, and we have 3 minus 2 is just going to be 1. But we do have something we can simplify on the bottom. So they may combine these. Instead of leaving this as something to the 6, they might break it up and say that this is x plus 3 to the 8 on the bottom. So either one is possible. And that would be our final answer. Okay, so for each, a little tricky looking here, we've got x cubed plus 3x times a cube root. So we're going to write this as x cubed plus 3x times 2x plus 2. Cube root would mean to the 1/3. A half is a square root. So we've got a product, f and g. So our product rule we know says do the derivative of f times g plus the derivative of g times f. So y prime, derivative of the first, derivative of x cubed plus 3x would be 3x squared plus 3 times the second, left alone, 2x plus 2 to the 1/3, plus derivative 2x plus 2 to the 1/3, so chain rule 1/3 out in front, times the bracket to the third minus 1. So 1/3 minus 1 would be negative 2/3. times the derivative of what's in the bracket, which would be derivative of 2x plus 2 would be 2, and then times the first, x cubed plus 3x. So we'll write these back as the roots rather than having the 1/3 here. So 3x squared plus 3 times cube root 2x plus 2. This one will leave the 2 on the top and the x cubed plus 3x on the top. And on the bottom, we'll move this back down. So this is 2x plus 2 to the positive 2/3. And they may leave that, or they might write it as a root. So here we have the cube root. This is, the bottom is cube root, and then it's being squared. So on the top, we'll just leave it alone. But on the bottom, we could say 2x plus 2 squared, and then cube root it. Okay, so now we're going to review exponential functions and their derivatives. So derivatives to memorize: e to the x, y equals e to the x, derivative is e to the x. So easiest derivative to calculate. And y equals a to the x is y prime equals a to the x ln a. So if we have y equals 2 to the x, for instance, then we get derivative 2 to the x ln 2. So it's ln of the base. If we had y equals 7 to the x, we get y prime equals 7 to the x ln 7. And of course, we have to remember the chain rule, product rule, and everything else. So if we have e to the 4x, then our derivative, we have to think, well, derivative e to the x is e to the x. Derivative e to the anything is e to the anything times the derivative of the anything. So we get e to the 4x times the derivative of 4x, which would be times 4. And so we would write that as 4e to the 4x. And so that's how we use the chain rule here. Okay, so let's do a bunch of examples. So find the derivative of each of the following. So part A, we've got 5 to the x, bracket, 2x plus 5 to the 10. So this is going to be a product rule. We've got an f and a g. So we need derivative f times g plus derivative g times f. So derivative 5 to the x would be 5 to the x ln 5 times g left alone. So again, that's f prime, that's g. And then we need the derivative of g. So derivative of something to the 10 is 10 out in front. Something to the 10 minus 1 is 9, times the derivative of what's inside the bracket by the chain rule would be 2, and then times the first. So this, all of this is g prime, and this is our f. And again, we can look at, factoring if necessary. So you have to look at the answers and say, what did they do? So we could take out a 5 to the x. We have a 5 to the x in both places. And we could take out 2x plus 5 to the 9. So what's missing on the first term? We're missing the ln 5. And we're missing 2x plus 5 to the 1. In the second place here, we've got 10 times 2, so we've got 20. We've got the 5 to the x, and we've got the 2x plus 5 here to the 9. So that would be our answer. And we could put brackets around that if you like. Okay, part B, f of x equals square root x plus e to the 5x. So we're going to write this before we start derivatives. We're going to write it as x plus e to the 5x all to the 1/2. Okay, so I want you to hit pause and I want you to see if you can do the derivative of this on your own. So we have the chain rule here, something to the 1/2. We have a half out in front. Same bracket, x plus e to the 5x to the 1/2 minus 1 is negative 1/2 times the derivative of what's inside the bracket. So derivative x would be 1, and derivative e to the 5x, think derivative e to the anything is e to the anything times the derivative of the anything. So it would be e to the 5x times derivative of 5x, which would be 5. So in here, we have 1 plus e to the 5x times 5. We can put the 5 out in front. The 2 is on the bottom already, so we leave it there. And this, something to the negative 1/2, can of course come to the bottom as something to the positive 1/2. And we could write that then as a root. So 1 plus 5 e to the 5x over 2 square root x plus e to the 5x. And that would be our final answer. Okay, so for C, this one's a little bit tricky here. We've got 3 different derivatives to do. So again, you can hit pause at any point and try the example and see if you can get the derivative correct, and then unpause. So the derivative of the first one here is a product rule. We do have an f and a g. And then we have a derivative in the middle, and then we have a quotient. So for our product rule here, we've got the derivative of x cubed, derivative of the first would be 3x squared times the second, e to the x, plus derivative of the second, derivative of e to the x is e to the x times the first, plus the derivative of e to the 10. E to the 10 is sort of a trick. There's no x in there, so the derivative of a constant is 0. And then we have quotient rule. Derivative of the top, derivative of 1 plus x would be 1 times e to the 4x, minus derivative of the bottom, derivative of e to the 4x would be e to the 4x times 4, and then times the top, and then all over e to the 4x squared, all over the bottom squared. So again, derivative of 1 plus x is 1 times the bottom left alone, minus derivative of the bottom, derivative of e to the anything is e to the anything times the derivative of the anything, times the top left alone, all over bottom squared. So we've got 3x squared e to the x plus x cubed e to the x, plus, so here we've got e to the 4x, and if we multiply this out, we have minus 4 e to the 4x, minus 4x e to the 4x, all over e to the 8x. And I guess what we could do is we could simplify just the first 2 terms here, because this is 1 e to the 4x minus 4 e to the 4x. So negative 3 e to the 4x minus 4x e to the 4x, all over e to the 8x. And that would be our answer. Okay, part D, x squared e to the 7x. What would be our derivative here? Well, this involves an x, the x squared, and e to the 7x involves an x. So we're looking at doing the product rule. So derivative of the first, f prime times the second, g, plus derivative of the second, g prime times the first, f. So f prime of x equals, so derivative of x squared would be 2x times the second left alone, e to the 7x, plus derivative of e to the 7x would be e to the 7x times 7 times the first, which would be x squared. So pause for a minute and see if you can factor this and tell me what your final answer would be here. So I would take out a common factor of an x and then e to the 7x as well. So we take an x, e to the 7x out in front. What would be left in the first term? We've got the x, we've got the e to the 7x, so we just need a 2. In the second term, we need the 7. We've got the e to the 7x. We have an x squared here and an x here, so we need another x. So that would be our final answer. Okay, part E, f of x equals 3 e to the 2x plus x squared. And what's our derivative here? So if we leave the 3, the derivative of e to the 2x is e to the 2x times 2, plus the derivative of x squared is 2x. And so our derivative is 6 e to the 2x plus 2x. Okay, in f, we have f of x equals e to the 2x all over x plus e to the x. So we have f over g, so we're looking at a quotient rule here. So we've got derivative of the top times the bottom minus derivative of the bottom times the top all over bottom squared. So go ahead, hit pause, and see if you can get the derivative here, what it would be.
Okay, so we've got derivative of the top. Derivative of e to the 2x would be e to the 2x times 2, or 2e to the 2x, times the bottom, x plus e to the x, left alone, minus derivative of the bottom. Derivative of x would be 1, plus derivative of e to the x would be e to the x, times the top, all over x plus e to the x squared. So if we multiply this out here and put this negative through, let's say I'll write this maybe just as a bracket first, multiply this out, and then I'll put the negative through after, just so I don't lose anybody. So here, 2e to the 2x times x would be 2x e to the 2x. 2e to the 2x times e to the x would be plus 2e to the 3x. Multiplying with the same base, we'll add our exponents. Here we have minus 1 times e to the 2x is e to the 2x, plus e to the x times e to the 2x is e to the 3x. And we've got all over x plus e to the x squared. So here we've got 2x e to the 2x plus 2e to the 3x minus e to the 2x minus e to the 3x, all over x plus e to the x squared. So I guess the only like term that we have here, we have the 2e to the 3x, and we have minus e to the 3x. And the rest of them are not like terms. So here we have 2x e to the 2x plus e to the 3x minus e to the 2x, all over x plus e to the x squared. Okay, so in part G, we have e to the root x. So pause and let's see if you can get the derivative to e to the root x. So I would write this first as e to the x to the 1/2 before I start doing the derivative. So the derivative here, derivative e to the anything would be e to the anything first, and then beside it times the derivative of this. And the derivative of x to the 1/2 would be a half x to the negative 1/2. So this would be e to the root x times, this 2 is already on the bottom, and if we move the x to the negative 1/2 down, it becomes x to the positive 1/2. So our derivative would be e to the root x over 2 root x. Okay, h. So again, hit pause and let's see if you can get the derivative. So we've got f of x is 7 to the anything. So if you think about the derivative of 7 to the x, the derivative of 7 to the x would be 7 to the x ln 7. So the derivative of 7 to the anything is 7 to the anything ln 7 times by the chain rule the derivative of the anything. So 7 to the anything, derivative is 7 to the anything ln 7 times the derivative of this anything. And the derivative of x squared plus x would be 2x plus 1. And that's it. That's our derivative. Okay, so for part I here, we have f of x equals 10 to the x times square root x squared plus 5x. So we have an f and a g. They both involve an x, so we have the product rule. So we have derivative f times g plus derivative g times f. Okay, so what would our derivative be? Well, we've got derivative of the first. Derivative of 10 to the x would be 10 to the x ln 10 times the second, square root x squared plus 5x, plus derivative of the second. Well, this is a root, so we want to write this as x squared plus 5x to the 1/2. It's easier for us to do the derivative that way, right? So derivative of the second, well, the derivative of something to the half would be a half out in front, bracket to a half minus 1 is negative a half, times the derivative of the bracket, which would be 2x plus 5. And then that's times the first, which would be 10 to the x. So there's a lot going on here. This is f prime, this is g, this is f prime here, all the way to here, that's g. And then this whole thing here is g prime, and then that's f. So a lot going on here in terms of algebra. So what would we do to this? Well, we would probably take the negative a half here and put it down to the bottom and make it positive a half and write it back as a root. So we have 10 to the x ln 10 square root x squared plus 5x. We'll leave the 2x plus 5 and we'll leave the 10 to the x because they're both on the top. And we'll leave the 2, it's already on the bottom. And then when we bring this x squared plus 5 to the negative a half down, it'll become positive a half, which means then we can write it as a root again. And so that would be our final answer. If they asked you to factor out a 10 to the x, you could do that, but it wouldn't clean things up and make it look much nicer. It wouldn't do a whole lot. There's a lot of algebra in that answer, so you can't get rid of it. Okay, and our last one here. So we've got f of x equals square root 3 plus 5 e to the 2x. So again, I want you to hit pause and see if you can do the derivative on your own and see what you get. So we've got 3 plus 5 e to the 2x. All in square root means all to the 1/2. So this is the chain rule. So derivative would be half out in front. Bracket to the half minus 1 is negative a half. Times by the chain rule, the derivative of what's in the bracket. And the derivative of 3 would be 0. The derivative of 5 e to the 2x would be 5 e to the 2x times 2. So that would end up being 10 e to the 2x on the top. The 2 right here is on the bottom. And then we could move this down and make it positive a half as our exponent. So I guess in the end, we could do 10 divided by 2 here is 5 on the top. And then we can write this back under a square root. So square root 3 plus 5 e to the 2x. And that would be our final answer.
I hope you found this video helpful. If so, see more videos in this playlist. Don't forget to join the Facebook Study Hub. Use the link in the video description box. Also, I hope to see you at my prep sessions, where I'll show you lots of tricks and how to ace your exam. I'll go through every problem that you need to solve, and you'll solve them with confidence by the end of my prep sessions. Many of our prep sessions are free, so go to prep101.com now for more details and to sign up. I hope to see you soon. Take care. Bye.